6.6 section in Aufmann talks about ratios and proportions. We're talking about essentially solving proportions. That's what we want to do. So before we get to solving proportions, that's the second part of our discussion. We have to first talk about ratios, and ratios then lead into proportions, and then we can solve proportions. Remember, solving tells us, or asks for some variable. X is equal to some number. That's what solving is. But we got to talk about ratios, then proportions, then solving. All right, here's our vocabulary and terminology. A ratio is the quotient of two quantities with the same unit. Roof rise, roof run. Rise over the run. If we're talking about a roof, it'd be the rise over the run. Oops, rise over the run. And that would be our ratio. A rate talks about different units, and this would be feet to feet or inches to inches. Down here it'd be salt in maybe milligrams. Water in liters, something like that. That would be a rate. How many milligrams per liter? That would be a rate. But we're talking about ratios, and then from a ratio, or a rate maybe, we can set up a proportion. And the proportion talks about an equation. That proportion is an equation that sets up an equivalence, or two sides of an equation that are equal to one another. Two ratios or two proportions that are equal to one another. In other words, let's see, Usain Bolt can run 100 meters in, let's see, 9.6 seconds. That would be equivalent to 400 meters in X seconds, something like that. So there's one rate. Here's one rate. And we want to set these equal. This is a proportion. That proportion is what we're gonna use to solve for this, for example, X seconds. That would be about 37, 38, about 38 or so seconds or so, about 38. Some people say that Usain Bolt should run the 400 meters now that he's finished the 100 meters and the 200 meters, and he's gotten gold records in each one of them. Why not try the 400 meters? He would be very, very, very competitive if he could continue that pace. But anyway, we're going to use the idea of proportions to solve those ratios. So let's solve the proportion 4 over x equals 2 over 3. The idea here is, let's see, well, if we take a look back at what we've got from rational expressions, if we've got rational expressions, we would multiply by, because we've got a rational expressions. Rational means we've got a fraction. Expressions or equations means we've got an equal sign. So we've got an equal sign. What we have to do is find our lowest common multiple. Lowest common, I suppose, denominator, or lowest common multiple of the denominators. We've got to factor that guy. We've got to factor that guy. Well, they're factored. Okay, list them as the first term is x, and the second factor should be 3, and then raise it to the highest power that we've got, 3x, and then multiply the entire thing by 3x. And the left side becomes 3x times 4 over x. The x's cancel out, and we'd have 12. The right side, 3x times 2/3, or 3x over 1. 3 cancels with 3 to give us just 2x equals 2x. And then we solve. Divide by 2. Divide by 2. I don't want to know what 2x is. I want to know what x is. So we've got to divide by 2. 2 divided by 2 gives us 1x, or just x. On the right side, on the left side, 12 divided by 2, 6. Done. And that's the way we solve. But what we can do is if we have one fraction equal to another fraction and nothing else in the equation, just one fraction on the left side, one fraction on the right side, what we can do is cross multiply. So I'm going to go down here and I'm going to say, you know what, let's start over and say, well, I got 4 over x equals 2 over 3, and see if we can get to this solution as well. We should. In fact, we will. By cross multiplying, what we do is we take this 4 times 3, and that should be equal to x times 2, or 2 times x. So 4 times 3 equals 2 times x, or 12 equals 2x, and sure enough, that's exactly what we got right there after we multiplied by our lowest common denominator. So the beauty of math is that sometimes we can take the red path, sometimes we can take the blue path, and just like in the matrix, we'll get to the same spot. If anybody remembers the matrix. Alright, well, let's see. If you don't remember the matrix, ask me about it. Divide by 2, divide by 2. On the right side, I got x equals 12 divided by 2, 6. Done. Same answer, x equals 6, x equals 6, taken either way. But I guess if we've got a ratio, or I guess a proportion of one ratio equal to another ratio, I would recommend just simply cross-multiplying and getting to the same spot that we were. So there's my recommendation, I guess, for any ratios and proportions. So we can do the same thing here. We can find the lowest common denominator, or we can just simply cross-multiply. If we're going to cross-multiply, I would have 8x, or 8 times x equals 4 times equals 4 times. Remember, it's all of this over here, so it should be x plus 3. Now we've got to just simply solve that equation. We've got an equation up here with fractions, and by cross-multiplying, if we've got one fraction and one equal sign, then we can cross-multiply. Now we just simply simplify. Distribute that 4 to everything in there. Positive times positive is positive. 4x. Second term, positive times positive. Positive 4 times 3, 12. Simply solve. We combine like terms and move the variables to one side, numbers to the other side, just like that middle school dance that we talked about. Numbers to one side, variables to the other. I've got over here on the left 4x equals, keep things in columns, helps out. Divide by 4, divide by 4. I don't want to know what 4x is, I want to know what x is. X, or 1x, equals 12 divided by 4, 3. Go back and double check. 8 over 3 plus 3 is 8 over 6 on the left side. On the right side, 4 over 3. Are they equal? Question mark. We can reduce this guy on the left. 8 over 6, divide each one by 2. 4 over 3 is the same as 4 over 3. Checks out. There's our answer. Checks out.